Welcome back, YouTube. Copper and Quarter here again. In today's episode, we'll be refining a 14-karat white gold ring. How much gold will we get this time? This is the ring we'll be refining. The ring weighs 5.43 grams, and we're expecting 3.16 grams of pure gold. Multiplying the 14-karat constant of 1.34, we determine that we need 7.28 grams of copper for our inquartation. 7.30 grams will do just fine. As usual, we'll start by inquarting our gold. This will result in a 6-karat or 25% gold alloy, suitable for base metal dissolution in nitric acid. First, we melt our karat gold along with our copper, using an oxypropane torch. Second, we add a little borax to remove any impurities. Finally, we pour our molten gold alloy into water, forming granules and increasing surface area. With our inquartation complete, we can start dissolving base metals in dilute nitric acid used in a previous refining. After approximately 3 hours, nitrogen dioxide gas production has ceased, and the reaction is complete. We decant our base metal, bearing solution in a clean beaker and perform a series of distilled water rinses. Again, using dilute nitric acid, we dissolve any remaining base metals. There should be very little reaction as most, if not all, base metals have already been removed. As expected, very little reaction was observed, indicating complete base metal removal. Since our dilute nitric acid barely reacted, we'll decant and save it in a separate container for use in a future refining. Again, using distilled water, we perform a series of rinses followed by a 5-minute boil and another series of rinses. In order to achieve high-purity gold, we dissolve it in a solution of hydrochloric and nitric acid known as aqua regia. A few drops of sulfuric acid are added to precipitate any lead that may be present. Next, we filter our gold-bearing solution using a filter flask and a Buchner funnel loaded with a slow-rated filter paper. A manual vacuum pump makes quick work of this process. We transfer our gold-bearing solution to a clean beaker. And we precipitate our gold using sodium metabisulfite. Let's perform a stannous chloride test to make sure our gold has completely precipitated. The stannous chloride test result is negative, confirming our gold has completely precipitated. After allowing our gold to settle overnight, we decant our solution in a clean beaker and perform a series of distilled water and hydrochloric acid boils and rinses. If we want to achieve the highest gold purity, we need to dissolve it a second time and repeat the previous steps. The stannous chloride test result is positive, confirming the presence of gold in solution and, most importantly, that our stannous chloride solution is working as it should. Again, we filter our gold-bearing solution. And transfer our gold-bearing solution to a clean beaker. We precipitate our gold using sodium metabisulfite. We perform a stannous chloride test and confirm that our gold has completely precipitated. Again, we allow our gold to settle overnight, decant our solution, and perform a series of distilled water and hydrochloric acid boils and rinses. The refining stage is complete and we can transfer our gold to a melt dish. We'll remove any excess water using a pipette. We're finally ready to melt our gold. Once melted, we'll add a little borax to remove any impurities. Sit back and enjoy the show. We were expecting a yield of 3.16 grams and obtained 3.10 grams, an excellent result. Again, if you enjoyed this video, please like and subscribe. Your support is highly appreciated. Thank you for watching, and we'll see you next time.